This video is going to show you how to identify hydrogen bonding within a molecule or between molecules, identify the part of each molecule which will take part in hydrogen bonding, and then show the interaction between two molecules using hydrogen bonding. Now this is very similar to identifying permanent dipole interactions, because hydrogen bonding is a type of those interactions. We say that because permanent dipole is about two opposites in two different molecules attracting, which hydrogen bonding does as well. So you'll see in this one it's the exact same steps as the previous video, and there's one slight difference this time. So as before, we ignore all the C's to H's, which will leave a C to O and an O to H. Now we're only interested in one of those bonds, so this is where you need to know which type of bond interaction is stronger. So we have learnt previously that LDF is the weakest, and then it goes PD-PD, and then we have hydrogen bonding, which is a type of PD-PD but it's much stronger. So you need to know which one's stronger to decide this part. So in this one, we could point out C to O using page 11 of the data book as a polar bond because they have different electronegativity values. So carbon is 2.5, oxygen's 3.5. We also have O to H, so oxygen we said was 3.5, hydrogen is 2.2. Now to decide which one to use, that's where this part comes in. So C to O is permanent dipole because it's not London dispersion forces. O to H is hydrogen bonding. So you need to know your hydrogen bonding definition, that it is when hydrogen is attached to N, O or F within a molecule and therefore interacts with the opposite one in a different molecule. So this diagram shows that definition. Because hydrogen bonding is stronger, that's the type of interaction you want to show here rather than the C to O. So we'll ignore the C's to O's here and just look at O's to H's. So we said before that oxygen was 3.5, so I'll put that in there. Hydrogen's 2.2, and that would then mean that oxygen is slightly negative because it's the higher value. So you want your wee signs at either end. So that is me now done 1 and 2. I need to show the same on this one. Again, as previous, this you'd be given the diagram of 1, you'd need to redraw it to show a second one. Easier to do it above and below or just to the side rather than beside each other so that you can show that interaction. So here we have oxygen again being negative, hydrogen being positive. So in this one, you've got two options again. You can show that oxygen going to the hydrogen, so negative to positive, or hydrogen to oxygen. Whatever one, it does not matter. Both are correct and both match the definition that hydrogen bonding is when a hydrogen is attached to either N or F, in this case O, and because of that we get it interacting with the opposite atom in a different molecule. Now be careful here, you don't want that O interacting with any of these hydrogens. It has to be the hydrogen that's also involved in hydrogen bonding in its own molecule, so you can't just choose a random hydrogen here. So I'll go for this oxygen here to that hydrogen, and that there is me showing the interaction. So again, this could be repeated as long as it has NO or F attached to a hydrogen, and that would make it the strongest type of force present. We don't have any other type of force that's stronger at this stage, and that's how you would decide whether it's PD-PD or hydrogen bonding, which section of the molecule to show the interaction from.